Hi there once again and welcome to another Expresso mechanic tutorial. And in this one we're going to be producing a rig to do what you see on the screen. What we've got is a man and he's floating possibly in space. He could be an astronaut, let's pretend that he is. And we can see that his limbs are gently moving. And this is done by creating a rig to produce random movement that can also be looped. In order to achieve this effect, we're going to be using predominantly Expresso. We will also make use of a tiny amount of Python within the Python node within Expresso. So just a little bit of that to do. But yeah, I mean, it works quite nicely, as you can see. We'll also take a look at what we've got in this file as well, which is another use for this, which is like a holographic type display thing. And this uses the similar sort of technique. It's just not as subtle. And I've also added a tracer in there so that you can see what's going on. So we'll have a quick look at this one as well because it is slightly different. But anyway, that's what we're going to be about in this tutorial. So without further ado, let's see if we can make this happen. The first thing we need to do is find our character. So if I search for rigged and I've got male clothed, that's the one that I wish to use. I'll drop him into the scene and we've got him there. Okay, fantastic. Let's get our character just set the way we want it. So we'll lay him down and then we can just work from here really. Take a look at where he is. If we grab a hold of his leg here, we'll just move it slightly over there and just put a slight bend in his knee perhaps. I mean, you can adjust this to your own needs. It's pretty simple, and once we've built the rig we can also make some further adjustments. Just move the legs apart slightly. His hands and arms, well, we can move these if we wish. Just again put a slight bend there and perhaps do the same here. Should be okay. Something like that I think will be okay. Let's think about what we can do next then. Well, we want these limbs to just gently, effectively rotate, but they need to do it in a very subtle way and they need to be able to be controlled so that they produce a random loop. Let's start by bringing in a null. And our null will be used to store all of the elements that are going to make up the rig. So that's going to be the center point of the rig. We can then bring in a circle and drop it into our null. The circle's way too big. It needs to be something like 5.5 in the radius so that it would just encircle the wrist or the ankle. So that's a good size for this. The next thing to do is bring in some more nulls. So we'll bring in 4, drop these under our circle, and then we'll rename them. And these will be just 0 points. So we'll call them Z0, capital Z0, Z1, Z2 and Z3, and then we'll copy each of these just drop that under there. I'm going to rename them anyway. Okay, so these will now be offsets, so I will call this O0, O1, O2 and O3. Helps if you do that properly. O3. So let's drop O3. Let's drop these into the zeros so they can go like this. Fantastic. So we've got things that far. Now our circle, we want to arrange as 0 nulls around our circle. So we'll select all of these and in our tools, select arrange, a long spline for the mode, and the spline we want will be our circle. And we can hit apply. Now, we can see that we've got those in there. What I'll do is select them all and go into my basic tab, or rather my object tab, and I'll change them to circles and make them about 1 in the radius so that we can just see them more clearly, and we'll also make them yellow. Great, so they now stand out really nicely. The next thing to do is with our offsets here. Let's just get that correct. I don't know what's with me and typing, I'm terrible. Okay, we've got our offsets ready to go. Now let's just select them all, and once again we'll change them and we'll make these diamonds, and again give them a radius of just 1. So they're easy to see, and we'll also change their colours to green. Okay, so we've got those there sorted out. Now what we actually need to do is randomise the positions of 3 of these diamonds from the 0 point. And we've set them up the way we have because if we check out our first offset here, we go into our coordinates, we can see that it's zeroed. So it can move away by a small amount in any direction. And we're always working from a point 0, and that's why we've grouped the way we have. Fantastic. So let's think about where we go from here. Well, the next thing to do is actually to select the circle and hit C, because we want this to be editable so that we can get a hold of its points. And we know that the circle will have 4 points because that's how a circle is made. And Bezier and uniform for the actual intermediate points is perfectly good, so we don't need to alter anything there. Next thing to do is bring in another null. We'll drop this into our parent null, and we need to give this an align to spline tag, and the circle is the spline that we wish to align to, and we're going to call this guide for want of a better name. So we've got that set up there, and this actually completes the rig. That's as much as we need to do for the actual objects that are going to be making up this rig. Moving on from here, we'll bring in another null and call it Expresso. We'll give it the Expresso tag. We've got the editor open, and we're ready to start adding some nodes. I'll just add some more frames. I'll make this 900 because that will be important. The first node that we need to bring in to our Expresso editor will be a time node, and we'll add a frame port, and we do need the time port as well on this occasion. We can then think about where we're going next. Well, we want to create a loop period basically for our random number generation, and we want this to loop every 300 frames, or at least that's what I'm going to use. You can change it if you wish, but in order to do that, we'll bring in a math node and we'll make it a modulo in the function, and it will be a modulo of 300, so 300 in input 2 there, and then we'll take the frame output port and plumb it into input 1. That's the first part of this complete. The next thing to do is to bring in an iteration node, so we'll bring one of those in, and this will be a start point of 0 and an end point of 2. We'll also bring in a linked list. So we've got our linked list here, and we can connect the output of the iteration to the index port. Now, the objects that we wish to loop through will be 3 of our offsets. Offset 0 will leave where it is. That doesn't need to move. The other 3 do. So we'll select those and bring them into our linked list. Moving on from here, we can think about bringing in the Python node. So we'll bring that in, and then we can start thinking about what we're going to do here. For a start, we'll get rid of both of the ports at the input stage, and we'll bring in 2 integer ports. Our top one will be called trigger, so we'll rename that trigger, and our bottom port will be index, and we've got that there. And we can connect the output of our modulo into the trigger and the output of our iteration into the index. So those will be the 2 suppliers of data that we'll be using within the Python node. Now at the output stage, we've already, if we check the port information here, we've got a real type there, and that's absolutely fine. We just need a couple more of those, so we'll add 2 more floats. And then we can rename these. This one will be X, and this will be Y, and finally, you guessed it, this will be Z. Okay, so that's our Python node set up and ready to go. We can switch to a coding layout, so a scripting layout here. We'll select that and open up our Expresso again, select our Python node, open in editor, and we're ready to start doing some work. Okay, what we need to do first is import the random module, so we'll do that at the top here, and this line is not necessary, so we'll get rid of it. We can then add some more global variables. So for a start, we need to define Y and Z at the output stage, so Y, Z, and then we can define 3 more, and they will be X underscore vals, Y underscore vals, and finally Z underscore vals. So that completes our globals. They're ready to go. Moving on from here, we need to check the value of our trigger, and we want something to happen when it produces a 0. So we can say if trigger is equal to 0, and then decide what we want to do next. Well, we need to set up these X, Y, and Z vals as lists. So X underscore vals is equal to an empty list. We'll copy this, paste it in, and change the X for a Y. And then we can do the same again and change the X for a Z. So we've got 3 lists set up and initialized at the beginning of our animation, and also whenever our trigger produces a 0 at any other point, which will be every 300 frames, because of course we've got the modulo at 300. Fantastic. Let's move on from here and see where we're going next. We can now start generating some random values and populating these lists, and we need 3 random values in each list. To do that, we'll need a for loop, so for I in range, and it will be 0, 3. And then we can think about generating our random numbers. So RND is equal to random.uniform is what we're going to be using on this occasion. So random.uniform and it will brackets -1, 1. So this will generate a real value, so a floating point value between -1 and 1. And this will enable us to create some very subtle changes to our nulls. So very, very subtle variations going on here, and that's really important. Fantastic. And then we can simply say x_vals dot append, and it will be random. We'll copy both of these lines, paste them in, change the x for a y. Same again, and change the x for a z. And that will give us 3 lists populated with 3 random numbers between -1 and 1. Fantastic. The next step is to sequence through these lists and output the values here. And to do that, we simply need to say x is equal to x_vals square brackets index, because the iteration here, we're using this to actually loop through these here. This for loop simply populates them, but this is what we're using to sequence through them and then output the values. We can then copy this once again, paste it in, change the x's for y's. Same thing again, x's for z's. And that completes the code. That's as much as we need in the Python. So very, very simple. This part populates the lists. This part outputs the values stored within the lists. And every time the trigger is 0, we clear the lists out and then we repopulate them and then we resequence through them. So it's a very, very elegant but very, very simple piece of code that does that job for us. Great. So let's think about moving on from here. The next thing to do is bring in one of our offset nulls. We'll bring in 01 for what it is. It doesn't really matter. And we can think about giving this some ports. Well, we want to get the actual nulls from our linked list and pass them to here. So we'll give it an object port and get that done. And then the values coming out of here, we want passed to our position x, y, and z for our null objects. So let's bring those in. So position x, position y, and finally position z. So we've got all of those, and we'll just bring this down to the bottom and just rearrange these as need be. And then we can plumb the outputs from our Python node into our 01 here. At the output stage, we also need our position x, y, and z. So we'll bring those in. Make this bigger so that we can see what we're doing, and then we can think about where we're going next. Well, we need a vector to reals, or rather, I beg your pardon, a reals to vector. So an adapter, reals to vector. We can plumb the outputs of 01 into the inputs of the reals to vector. Moving on from here then, the next thing to do will be to bring in a point node. So we'll bring one of those in. And we can think about giving a point position node at the input, placing this at the top, and we can plumb the output of our vector to reals into the point position. Now, where do we go from here? Well, the object index that will actually be used to take the output of the iteration. But we must also bring in a math node. So we'll bring one of those in. It does need to be a math add, and we'll plumb the output of our iteration into the input number 1, and we'll add 1 to this, and then we can plumb that into the object index. The reason that we've added 1 is because the object that we actually want to work with will be the circle. So we're going to bring that in, give it an object port at the output stage, and then all we need to do is plumb it in to our object port. And we can see that straight away we've got a tangle. We've got a tangle there. And that's fine. That's what we want. We want this to be a tangled shape because we want it to create a kind of random motion. And that's exactly what it's going to do in its tangled state. And if we actually run our sequence, this part will actually work. So let's do that. Let's just run this and see what happens. When we get to 300 frames, you should see a change. And we do. We can see that that's moved. And we can see that the shape of our circle has slightly changed. It's only a subtle change, but it's a change. And again, it's changed. You can see the shape has changed. So we're getting this squiggly sort of shape, and that's exactly what we want to create this random motion. But because we've added 1 to the iteration, we've avoided using 0.0, and that gives us a perfect loop. Now, we're not finished yet because, of course, we've still got something we need to do. We need to be able to move our guide around our circle, and that's the next part of this expression. What we need to do is bring in a compare node. So we'll get a logic compare, place this up here, and we can plumb in our frame into the input 1. And we can say in our function greater than or equal to, and it will be 1. So when we're greater than or equal to 1 frame, we want something to happen. But we need a bool, because we want to check 2 things. So we'll bring in a bool, and it does need to be an AND in the function, and we need to plumb the output of our compare into input number 1 and the output of our modulo into input number 2. Okay. So when our modulo produces a number 1 and our compare produces a number 1, we're going to get a 1 at the output stage. We're going to get a true output. And when that happens, we can use this to trigger a monoflop. So let's bring one of those in. So we've got our monoflop here. We can plumb this into the trigger. Now at the moment it's not set up correctly because it's in normal mode. We need it to be in one-shot mode, because obviously we want to trigger by a 1, and that's how one shot works. If you set it in normal mode, you trigger with a 0. Now we need to get a time port from our time node and plumb that into there, and then we can set our duration, and that will be 300 frames because we want that to be our loop period. And then we simply need to get our state port at the output stage, which will give us a value between 0 and 1, and then we can plumb that into the position of our align to spline. So tag properties, position, and that completes our expression. Let's see what happens now. So let's see where our guide is. Now our guide, if we select that, let's just change that so that we can see it more easily. Just change it to something like, let's see, let's have a pentagon. That will do, and we'll leave it quite large so that we don't change it. We'll see this really easily now. We just play the sequence, and there we go. We can see that that's following around our spline, and we can see that there's a kind of random motion being generated there. And this will be different now because the circle has changed its shape. Subtly different, but different. And that's exactly what we've been going for all the way down the line. Subtlety. That's what we want. And there you go. It's working fine. So let's just take that away and we'll make it back to a dot. Fabulous. The next thing to do then is to apply this rig to one of our limbs of our character. We might as well start with his right leg. Before we actually move our rig, we need to be mindful of something. Now at the moment, if we select it and we move it, you can see that that's definitely not moving properly because this needs to move with this. We just zero that out. The reason that isn't working properly is because if in our point node here, we've got the matrix mode as global. It actually needs to be local. And now we can move the whole rig and it's working okay. So that's the last step within the Expresso. Make sure you do that. We'll rename this right leg and we'll think about moving it. And it's got to move to here. And if we open up our character, we can see that this is right IK leg control effectively. So that's where we need to move to. So we'll select our right leg and in our tools transfer, it's already in there, but if that wasn't there, just drag this into here and then hit apply and the rig jumps to where it needs to be. In order for the rig to take control of the leg though, we've got to produce another little Expresso expression. So we'll bring another tag in. We've got the window open and we can think about what we need to do. We need to use our guide as the object which will move our leg around. So we need our global position and then we also need our characters RIK leg control. So we'll bring that in and we need to take control of the global position of that. And we can see that the leg has moved into a start position, which is at the 0 point of the leg, or the 0 point of the leg, the 0 point of the circle. And if we play, we can see it's working. It's giving us the motion that we want. Yeah, and that's working quite nicely. Now, as we've got the guide being the controller, if we take a hold of the right leg's null, we can move the leg and we can art direct things by just moving this around. So that's quite nice. And we can see that it's working. And when the loop point happens, you can see that there's no glitching. It's just a perfectly smooth loop. Now that knee there is a little bit dodgy. So again, we can just move this back a little bit if we don't like that. And that will help to solve that problem. That's a bit better. But yeah, it's working really nicely. And that's great. If we want to take control of his left leg, what we can do is command drag to copy this rig. And then the first thing to do is switch off the Expresso because we don't want it interfering with the right leg. And we can then rename this left leg. Again, we need to transfer it, but at this time it needs to go to this. So it's got to go to the left IK leg control. So left leg, transfer, and this time we're going to here. Drag this in, hit apply, and we've moved the rig across. In order to get it to work, there are a few things that we need to do within the Expresso. For a start, if we open our first expression, we know that this was the right legs controller. We want it to be the left, so we need to bring this in to here. And that set that up okay. And then in our second expression, we need to do some adjustments in here. For a start, the align to spline, that needs to be our align to spline here, so we'll drag that in. Our circle needs to be the circle from our left leg, so we've got those two sorted out. This link list we can clear, and then we can repopulate it with these three, and now we should be okay because everything else is set up and there's nothing else that we need to really worry about. So we can close the expression, and then we can select both of these and bring them back to life, and we can see straight away that the left leg has moved into its 0 position. And now if we run our sequence, we can see that they're working. Now, one way that we can make them slightly different, if we go into the circle here and into our spline menu, we can go down to our point auger and reverse the sequence, and that can give us quite a nice effect. If we just run that now, they won't be alike. You can see that they're both moving in different ways. That's quite nice. So that's one little trick that you can use if you think they're too similar. Just reverse the sequence of one of the actual splines and you'll get a complete difference. Fantastic. So that's working really nicely. I won't bother doing the arms because just for the sake of time really, but it's just follow the same technique. If you want to do the arms, just switch off, Command Director Copy, switch off both the expressions, do the adjustments and then switch them back on. That's all you need to do. It's just a rinse and repeat. What we can do next is have a look at our holographic display and see what we can do with that. We'll just go back into here and just stop the sequence. That's it, just to make sure everything's okay. Just stop that there. That's it. Okay. With the holographic display, it's very similar to what we've got in the floating man rig. But what we've got in here, if we open this, we've got a circle again, but 0.0, what we've actually done, and you can see that I've got one null, which I've named scene. I could call it rig, but I've just named it scene. And it's got everything I need in it. So the 0 position of the scene null is the 0 point for our circle's 0.0. So I've got that set up there. Again, my matrix mode here I've got set to local, and then in my main expression it's virtually the same, but on this occasion we don't have a modulo and we don't have a bool. We've just got the compare, and that is again greater than or equal to 1, and that's triggering our monoflop and moving our guide along, or in this case it's not a guide actually. I used a platonic object. This green platonic object is the thing that's being moved along the actual spline by the align to spline. In the Python here, we just opened that up. This is identical, except that our for loop is 0 to 7 because I've got my targets here and I've got 7 of them. So I've got 7 nulls that I'm going to be using to take control of the points, or the points 1 to 7 of our spline, our circle. And the numbers are slightly different. So 0 to 7 for a start in the for loop, and then the actual random numbers are between -120 and 120 on this occasion. So it's a much bigger, it's just less subtle. That's the key thing. It's a bigger thing. And obviously the linked list, all the targets that I need are in there. 0 through to 6, they're there. And the iteration, of course, is iterating between 0 and 6. The math add is still exactly the same because we want to ignore 0.0. And that really is the only difference. It's exactly the same other than that. And then I've just simply added a tracer in here so that you can just see what's going on, and it just creates this holographic display type thing going on there. And again, because we've got it grouped into a scene null, we can just move the whole thing around. And it works anywhere in the scene. And that is how you go about creating loopable, if indeed that's a word, random motion. And it works quite nicely. It's just a shame that we have to build rigs to do this. I mean, ideally, it would be better if we could just give the Expresso null a vibrate tag. If we could come into there, just give it a vibrate tag. The problem with it is that nothing is loopable. I mean, you know, you've got a regular pulse, but that's no good. It's no good whatsoever. You know, there's just nothing in there that can actually make any kind of loop. So that doesn't work. And similarly, if we go into an Expresso here, we've also got a noise node. If we go down to our noise here, bring this in and have a quick look at it, we can see that we've got noise types. We've got a number of different noise types, but again, none of them can be looped. We've got positive only. Well, no good to us whatsoever. And we've got a few controls down here, but unfortunately, no, it's not going to help us. It's just no good to us whatsoever. There's no way that we can create a loopable noise within Expresso or Python. There's just no way that you can do it. So you've got to build a rig. And at the moment, that's the only way we can make this work. But so it is a workaround, and it might be worth actually contacting Maxon and saying, look, can you make the actual vibrate tag have an option for loopable motion? You know, that would be a really great thing. I mean, if it did, if there was a checkbox in there to make it loopable, and then you could have a parameter field for, say, the actual loop interval like we've created by using the modulo. Yeah, that would be fantastic. It would be a really great feature, and it would speed things up, wouldn't it? It'd be, you know, you could just instantly do it with a tag rather than having to build a rig and sort things out like all of this. I mean, it is quite long-winded to actually set this up, but unfortunately, as I say, there's just no other way you can do it. If it's not there in the tools, you've got to find a workaround, and this was the workaround that I came up with. So yeah, I mean, if you think that would be a good feature for the vibrate tag, please contact Maxon and ask for the feature. You never know, they may think, yep, that's a great idea, we'll incorporate it. You can but try. But anyway, that just about brings us to the end of this tutorial, because I've shown you the things that I wanted to, and I'm hoping that this will be of use to you and you may be able to use something similar in some of your projects, and I'm hoping that it's inspired you to give this stuff a go. And if you have enjoyed the video, please give it a like, and if you haven't already, please subscribe to the channel, leave a comment, and of course ring the bell. And wherever you happen to be on social media, please do share this video, because all this good stuff really does help keep the channel moving in the right direction. But anyway, that just about brings the curtain down on this one, so I'll see you very soon on the next tutorial.